Okay, we are continuing on with factoring. We're still sticking with this trinomial idea, but today we are factoring, but we're adding a leading coefficient. So we were factoring in our previous lesson where the leading coefficient was 1. Today we are going to factor, but it's going to be ax squared plus bx plus c. It's still going to be to unfoil, but we are going to have a leading coefficient today. So we're going to have this leading coefficient, and I'm going to turn this around because I'm going to do a problem on the whiteboard behind me. All right, so there we go. All right, so again, just to recap, let me get a marker and my eraser. All right, so previously, right, we had of the form x squared plus bx plus c, right? So we have, let's go with x squared, let's do minus 4x, and hold on, I have to think of a problem that works. Minus, I'm gonna have to change this. Let's do minus 20, and let's do 8x here, right? So we looked for factors of negative 20. So to get a negative, we have to have a positive and a negative value, right? That have a sum of negative 8. So we're looking for factors of negative 20. So what times what makes negative 20? So my options are, to get to 20, I can do 4 and 5, or I can do 2 and 10. So which one would give me a negative 8 sum? Well, negative 10 plus positive 2 creates negative 8, but negative 10 times 2 makes negative 20. So this answer would be x minus 10 and x plus 2, right? So we're going from the basics of just factors of c that have a sum of your b value, right? That's all we were doing in our previous lesson. Today, we're going to have a leading coefficient that we're going to have to add in to our problems. So let's start. I'm going to reverse and turn, and here we go. So factoring ax squared plus bx plus c, which is again unfoiling. We're going to have a binomial times a binomial because we are getting a trinomial answer. So today is a trinomial where the leading coefficient is not 1. It's not equal to 1. And so it's really similar to what we did previously. In fact, it's the same rule, except we don't multiply in our previous one, but it's factors of a times c that have a sum of b. Now, in our previous problems, we really did this. We just glossed over it. We skipped it because our a value in our previous lesson, the a value was 1. And so 1 times c, that doesn't do anything, right? So we just didn't even think about it. But today, our a value is going to be a number other than 1. And so we're going to multiply a times c to get a sum of b. So we have some questions to ask ourselves. First question, question number 1 that we always need to ask is there a GCF, right? Is there a GCF, or is the leading coefficient IENT negative? Right? If the leading coefficient is negative, or if there's a GCF, you need to factor that out first. After you do that, you're looking for factors of A times C that have a sum of B. And then these two factors that you come up with, whatever your answer is, these are going to replace the BX in the problem. So we're taking our trinomial and we're replacing that middle term, that middle BX term. We're replacing this middle BX term with two values, with the two factors. So we're taking a trinomial and we're making it now into a 4-term polynomial. And since now our trinomial is now a 4-term polynomial, you're going to factor by grouping. We're going to split it in half and factor. So let's do some practice. Let's start. So again, is there a GCF, or is the leading coefficient negative? Take that out first. And if you still have an A value, right, it's not 1, you're looking for factors of A times C that have a sum of B. You're going to replace that BX, that middle term, with those two factors. Our trinomial now became a 4-term polynomial, and we're going to factor by grouping. So 2x squared plus 11x plus 5. So first question, is there a greatest common factor? Can something come out of all of these? Well, no. 11 is prime, 5 is prime, we're stuck. So I'm looking for factors of A times C. So A times C is 2 times 5, which is 10. So factors of 10 that have a sum of 11. So factors of 10, what times what makes 10, but when you add it, you get 11. So my answer is 10x and 1x. 10 times 1 is 10, and 10 plus 1 is 11. So I'm going to replace 11x with 10x and 1x because that makes a true statement. So my problem now is going to become 2x squared plus 10x plus 1x plus 5, because I'm replacing this middle term, this bx term, with these two values, because 10x plus 1x makes 11x. So it's still the same problem. I just split this 11x into two factors. And the factors I picked were factors of A times C, factors of 2 times 5, which is 10, factors of 10 that have a sum of 11. So I replaced it. And since I've replaced it, I can now, because it's a 4-term polynomial, split it in half and factor each half. So I'm looking for 2x squared plus 10x. I'm looking for the greatest common factor there, which is 2x. And I'm factoring that GCF out. What is remaining? 2x squared divided by 2x leaves me with just 1x behind. And positive 10x divided by 2x is positive 5. I'm looking at my second half. What is the greatest common factor of 1x and 5? The greatest common factor is 1, so positive 1. And what does that leave behind? Well, 1x divided by 1 leaves me behind with just x. And 5 divided by 1 leaves me behind with 5. And we know that we did this correctly because my leftovers, if you will, match. So the final answer, when you factor by grouping, the GCFs go together, 2x plus 1, and the leftovers go together of x plus 5. And there is my factoring. If you were to FOIL this, your end result would be 2x squared plus 11x plus 5. Let's do another one. Let's do 18x squared plus 3x minus 5. So first question, is there a GCF or a leading coefficient that's negative? 18, 3, and 3. So 3 and 3 are prime, so they can only be divided by 1 and 3. Can 18 be divided by 3? Yes. So my greatest common factor is 3, which leaves behind 6x squared plus 1x. I'll put the 1 in. You don't have to. And then negative 3 divided by 3 is negative 1. So I have a leading coefficient that is not 1. So I have to look for, I'm going to circle this and I'm going to draw it down so that I don't forget to bring that with my problem. I'm looking for factors of a times c, which is 6 times negative 1, which is negative 6. So factors of negative 6 that have a sum of 1, right? Factors of a times c that have a sum of b. All right, so to get negative 6, I have to have a positive and a negative. 3 times 2, how do you get a positive 1 from 3 times 2? Positive 3x and negative 2x. 3 times negative 2 is negative 6. 3 plus negative 2 is 1. So I'm going to replace my b value with this b value with these two problems. So 6x squared plus 3x minus 2x minus 1. Now it doesn't matter which one you put first. Again, it's going to be the same result no matter what that looks like. So I'm going to split it in half. And I'm going to factor. The GCF of 6x squared plus 3x is 3x, which leaves behind 6x squared divided by 3x is 2x, and 3x divided by 3x is positive 1. My second half has a leading coefficient that's negative, so I'm going to take out a negative, and 2x and 1 have a greatest common factor of 1. Negative 2x divided by negative 1 is positive 2x. And negative 1 divided by negative 1 is positive 1. I know I did it correctly because my leftovers match. So greatest common factor, 3x minus 1. 2x plus 1. And I had a GCF at the beginning that goes in front. We're going to keep practicing. Next page for more practice. Let's do 15x squared plus 4x minus 3. Is there a GCF? So 15 factors are 3 and 5. 4 is 2 and 2. No, there's not a GCF. So I'm looking for factors of a times c. So 15 times negative 3 15 times negative 3 is negative 45, that have a sum of 4. So to get negative 45, I have to have a positive and a negative. So what times what makes 45? But how do I subtract them, right? One has to be negative. How do I get 4 out of that? 9 and negative 5, is that right? 9x and negative 5x. 9 times negative 5 is negative 45, and 9 plus negative 5 is 4. So I'm going to replace my middle term with 9x and negative 5x. 15x squared plus 9x minus 5x minus 3. I'm going to split it in half. I'm going to factor 15x squared plus 9x. That greatest common factor is 3x, which leaves behind 15x squared divided by 3x is 5x, and 9x divided by 3 is positive 3. I have a leading coefficient that's negative, so I'm going to take out a negative, and 3 and 5 are both prime, so the greatest common factor is 1. Negative 5x divided by negative 1 is 5x, and negative 3 divided by negative 1 is positive 3. I know I factored correctly because, I forgot that parentheses. Leftovers match. So my answer is greatest common factor, and leftover. Let's do another one. Let's do 4x squared minus 9x plus 5. Let's see, greatest common factors. 4 can be divided by 2 and 2. 9 can't be divided by 2, so I'm done. I'm looking for a times c, which is 4 times 5, which is 20. And I want a sum of negative 9. So if I want a positive value, I either have 2 positive factors or I have 2 negative factors. To get a positive multiplication but a negative addition, you have to have at least one negative, right? So that means that this needs to be a negative and a negative. A negative times a negative is a positive, and a negative plus a negative is a negative. Factors of 20 that make negative 9. Negative and negative. Negative 4x and negative 5x. So I'm going to replace negative 9x with these two values. 4x squared minus 4x minus 5x plus 5. Again, negative 9x gets replaced with these two factors. I'm going to split it in half. And I'm going to look for GCFs. The GCF of this half is 4x, which leaves behind 4x squared divided by 4x is x. Negative 4x divided by 4x is negative 1. My leading coefficient here is negative, so I'm going to take out a negative. Oh, negative 5 is what's in common. Negative 5, right? They can both be divided by 5. Negative 5x divided by negative 5x is x, and positive 5 divided by negative 5 is negative 1. I did it correctly because they match. And my answer is 4x minus 5, GCF, GCF, and x minus 1. Now, I know that there are some students that are like, okay, Mrs. Long, what happens though? Like, I'm worried about not putting these two middle terms in the right order. It does not matter. You will get the same answer. So if I rewrote this problem, if I did this problem here, and I did it the other way, if I did 4x squared minus 5x minus 4x plus 5, right? I switch the order here. I use the same numbers, I just switched the order. Right, let's say that you wrote it down negative 5x and negative 4x. That's okay, because I'm going to split it. The greatest common factor here, 4x squared minus 5x, is just x, right? Which leaves behind 4x minus 5. And over here, the greatest common factor, there's a negative leading coefficient, and 4x and 5 have a greatest common factor of 1, which leaves behind 4x minus 5. They match, right? So my GCF and GCF, x minus 1, and my leftovers, 4x minus 5. And look, they're the same problem, because order does not matter when you multiply, so these are the same problem. It does not matter the order that you put your two factors that you find to replace your middle value. If you want a rule, go with smaller than bigger value. Doesn't matter. It's going to get you the same result as long as your math is sound of what's going on. So let's review really quickly before you start working independently. Is there a GCF or a leading coefficient that's negative, like this problem, right? We had a GCF that we took out to begin with. And then if that helps, you can cross this out so you don't get confused of what you're working with. Then you're looking for factors of A times C that have a sum of B. So you're taking your A value times your C value, and you want factors of that number that have a sum of B. Then you rewrite the problem, because instead of that middle value, you're using your two factors, because these two factors added together create that middle value. That's that sum of B. So you have to replace that, right? And you need your variables attached to it. And because you now have a trinomial that turned into a 4-term polynomial, right? Our trinomial now is a 4-term polynomial because I divided up that middle term into the two factors. I'm going to factor by grouping. I'm going to split it in half, find the GCF of the first half and the leftovers, and find the GCF of the second half with the leftovers. My leftovers match. That's how I know I did it correctly. GCF number 1 and GCF number 2 make the first binomial, and the matching leftovers are the second binomial.